Type challenge 3, baby. We're doing tuple to object. And tuple to object, given an array, transform it into an object type, and the key value must be in the given array. So given that we have this little array of Tesla, Model 3, Model X, Model Y, it should become, in the type land, a object with Tesla, Tesla, Model 3, Model 3, Model X, Model X, Model Y, Model Y. Same thing with these numbers, same thing with a mixed array of numbers and things here. The first thing to notice is that calling these arrays is not quite right. These are tuples. Arrays, they would let you push to them. You know, I'd be able to say tuple.push, blah, 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 and I could push something to it, but I can't because a read-only array, you can't append to it, you can't modify any of the members, can't do anything like that. And the reason that's happening is because we're using asConst here. If I were to take away asConst, then a lot of this inference would go away. This would be inferred as just string here, this tuple. Whereas when I add asConst, it actually adds the read-only sort of like modifier to it, whoop, just there. And it also like infers these as their literals, which makes this whole thing work. If TypeScript didn't infer these as their literals, then it just wouldn't work. So, okay. Well, the first thing we need to be able to do is try and extract all of these members, like of this tuple, into some kind of type, right? We need to access the members of the arrays. So I'm going to say type array member equals, let's say we've got type of tuple. We're using type of to turn it into a type, right? So we've got this sort of inference happening here, and then now array member is going to be inferred in exactly the same way because we're just grabbing type of tuple there. So the way we would access one of the members is we would say like 0, right? Which is going to access the first member of that array. So then we've got Tesla in there. If we want to access Tesla or Model 3, then we can actually pass in a union type in here and access it via a union type. So we've got Tesla or Model 3. If we want to do like all three of them, we can do that. But this isn't going to scale and it's not going to work with like, I don't know, a tuple with tons and tons of stuff in it. So we can actually say tuple number. And tuple number, now number represents a union type of all of the possible numbers. That's how TypeScript treats it in this position, meaning that we end up with Tesla or Model 3 or Model X or Model Y. That's real good. So we can use that to our advantage later. So inside this helper then, we've got this T. I'm going to rename this to TTuple for clarity. And what we've got then, so this, it's already given us some constraints here, which it doesn't usually give us. It's saying that this must extend a read-only any array. So it must extend a tuple, basically. But it's still just returning any, which means that these cases are failing. So we know then that we need to create an object out of this. And when we do create an object, it's going to be like a, we need to be thinking about a mapped type, an object map type. So for that, we can create a new object and we can give it a dynamic index. And that dynamic index is going to be something like this. So we can say, the way you create a dynamic index when you're not using key of is you can say like tindex in ttuple number. And for that, I'm just going to say like 1 for now. So let's say we've got type blah equals tuple to object, and then we'll say 1, 2, 3. So already, if I just say like in there, then we've got 1, 2, 3 are being taken from that tuple and given this crazy value here. So that's working because we're basically iterating over each member of ttuple number, which is the same as this, and then we're getting this tindex property here. So the final question is, how can we then reuse that tindex here? Well, it turns out that this is like a variable declaration. So we can just use it. We can just say tindex is just here. And if I get rid of all this, well, in fact, if I show you, we've now got it working. Very, very cool. So we'll get rid of all that crud. And what we've got then, yeah, ts expect error. Why ain't that working, eh? Tuple to object. I don't understand what that's supposed to be doing there. That's real weird. But all the cases are actually working, which is just fabulous. Tuple to object. Oh. Oh, that's really interesting. So it's expecting this to error. Now, there's a reason why it's expecting this to error. Because even though all of our cases are working just here, this is not really a valid tuple. What we want is, the reason this isn't a valid tuple and the reason it wants this to error is because the members of the tuple should all correspond to something. They should all be either strings or numbers, because those are the only things that you can put into this object here. So those are the only things that are valid object keys. So the way we want to solve this then is, like, you can't put a tuple as the keys in an object for another tuple. You know, it just doesn't make sense. So we need to make sure that everything that's passed here is a property key. And luckily TypeScript gives us something to help with that, which is there's a type equals property key. And property key, if you see here, it's either string, number, or symbol, because you can use things like symbol.iterator for object keys and stuff, but mostly string or number is what we're interested in. So I'm wondering if I do property key like this, if this will go away. Yeah, there we go, because if we remove the error directive or expect error directive, then brr is not assignable to type property key. There we go. Bam. So, okay. So we've got this kind of interesting constraints here. If I remove read-only, what happens? Yeah, then this isn't assignable. So read-only isn't read-only and can't be assigned to the mutable type property key. This, okay. So we need the read-only because read-only indicates that you must pass a tuple into here. You can't pass anything that isn't a tuple, which is a cool constraint. Then obviously all of our cases are passing. All of this looks very useful and handy. And property key just gives us kind of everything we need and errors in the right way. Beautiful. Well, thank you so much. I'll see you in the next one. I hope you're enjoying this Odyssey. I'm kind of enjoying working through these. They're pretty fun. You can check out the repo in the thing below, and you can take the challenge yourself and see if you can come up with a better solution than I did. So, cheers, everyone.